Save the Fish by Lena Mia and Samaa Hossein. One sunny day, Lena went down to the bay to observe cannibalistic crabs for her daily inspiration. On her way, she saw a fish dying and suffocating on the shore. The fish seemed to be trying to tell her something, so she picked it up. Hi, that was embarrassing, but let me introduce myself. My name is Samaa, and before you ask, I died because of this funny thing called eutrophication.
Whoa, dead fish spirit, slow down. What now?
Eutrophication is the excessive richness of nutrients in a lake or other body of water, frequently due to nutrient runoff, which causes a rapid algal growth. Algae dies quickly, which then consumes all the oxygen other organisms need to survive. In this case, my lake was polluted with a phosphate-based fertilizer.
What kind of person would do that? That's terribly horrid.
I don't know, but I hope my future generations don't suffer the same fate.
Do not fret, Bitchie. I will get to the bottom of this to help clean the lake and protect your lineage.
Yippee! Lena embarked on a journey and came across Mr. Dean, who worked at a wastewater treatment facility, or WWTF for short, in an unspecified industrial area.
Oh my gosh, Mr. Dean, since when do you work in a WWTF? Whatever, doesn't matter. Some of the fish is dead.
Oh, was it physics that killed her? That is quite the tragedy.
No, it was because of phosphate-induced eutrophication.
Oh no, that must have been breathtaking.
This is a serious issue. What can I do to make sure more fish like Samaa don't die?
Well, you could also use ferric chloride. Ferric chloride is used to decontaminate water and get rid of pollutants like phosphorus. It follows a 7-step method: screening, aeration, coagulation, sedimentation, filtration, chlorination, and supplementary treatment. The chemistry behind it is that ferric chloride, which precipitates phosphate from the water in the reaction, ferric chloride plus phosphate gives you iron phosphate plus 3 chloride. This converts phosphate molecules into iron 3 phosphate solids, or flocks, which bind with other particles so they can be physically removed from the water.
Okay, I think I could try that. It would work, right?
Yeah, of course, Lena. Ferric chloride is a spectacular coagulant that keeps water clean, prevents eutrophication, and can be used over a variety of pH levels.
That sounds promising. I'll go give it a try.
Samaa the fish, where are you? I'm here.
I found an amazing solution to clean the lake. Mr. Dean gave it to me, so it should work.
Okay, well, let's see what the formula is. We need to use gravimetric stoichiometry to determine the quantity needed to purify the lake.
Okay, so data collected by a 2025 study reports that phosphorus concentration of 16 milligrams per liter is commonly found in urban wastewater. We can use this quantity to calculate the minimum ferric chloride required to precipitate phosphate in the reaction, along with the resultant masses of each reactant and product. For ferric chloride treatment in 1 liter of wastewater, there are 16 milligrams, or in SI units, 0.0616 grams of phosphorus. We need moles of phosphate first, so to do that, let us find the moles of phosphorus and use that to obtain the mass of oxygen. So moles equals mass over molar mass. The mass of phosphorus would be 0.16 grams over 30.97 grams per mole. And then oxygen and phosphorus are in a 4:1 ratio, which we need to multiply by the moles of phosphorus to get the moles of oxygen. After this, we must get the mass by using mass equals moles over times molar mass. So multiply the moles of phosphorus by its molar mass and the moles of oxygen by its molar mass, and add them to receive the total mass of phosphate in its moles. Do the math part, Bitchie!
The moles of phosphorus would be 0.00052 moles, and the moles of oxygen are 0.00207 moles, meaning the combined mass of phosphate would be 0.00052 times 39.97 plus 0.00207 times 16, which would give us 0.049 grams of phosphate for 0.0052 moles of it.
Okay, so now to solve for the minimum ferric chloride needed, we will use the formula FeCl3 plus PO4 gives you FePO4 plus 3Cl. FeCl3 and PO4 are in a 1:1 ratio, so to find the FeCl3 we needed, we can do 0.00052 times 55.85 plus 3 times 35.45. Once we have that, we can find the amount of FePO4 that has precipitated and will be filtered out. To do this, we need to do 0.0052 moles times 55.85 plus 30.97 plus 16 times 4. And since you're so smart, can you also calculate the chlorine dissolved in the water by doing 0.0052 times 3 times 35.45?
According to my calculations, there are 0.84 grams of iron chloride required, 0.078 grams of iron phosphate is precipitated, and 0.055 grams of chlorine is dissolved in the water.
So, for every liter of wastewater, a minimum of 0.084 grams of ferric chloride is required to precipitate 0.049 grams of phosphate. Now that we have what we need, let us put it in the water and collect the precipitate. Yay, the water should all be clean now.
I don't think it's working. Ah! There are even more dead fish now! No!
Oh no, what's happening?
Wait, did you read the fine print?
Oh my gosh, I didn't. It says it's corrosive, it erodes almost everything except 318 stainless steel, makes water more corrosive, harmful for aquatic life by increasing salinity of the treated water, hazardous for water is used for irrigation. It also causes long-term issues to the aquatic ecosystem and adjacent environments after the water has been treated. There are heavy metals found in the final product. This includes high quantities of manganese, zinc, and chromium, which are toxic and may cause bioaccumulation. No, used for industrial purposes only. Oh no, what have I done?
Ha ha, you didn't read the fine print.
But that was a terrible idea. Why would you ever agree with it? You should have done what they did in Sudan. Eco-friendly substitutes derived from natural sources. Ones like moringa, alfaro seeds. That were effective in getting turbidity and resistance in water in rural communities. Would have been an environmentally friendly alternative that causes no harm to both people and aquatic life. Therefore, it should be implemented to preserve the natural world and avoid chemicals that do more harm than good, especially since it ends up killing our entire fish population. Please don't forget about us and read the fine print next time.